Members, today our chemistry, we are going to focus a lot on what we are calling titration, what we can also call quantitative analysis. Now, this quantitative analysis, members, this is mainly a technique, or we can say a skill of determining what we are calling molarity or concentration, but by taking advantage of the neutralization between the acid and the base. So in this chemistry here of titration, we always need the following apparatus. When you look at the apparatus we need, you'll discover that we need the following apparatus. The burette. So the burette, which you are talking about, we may have different categories of burettes. One of the burette can be like this one here. This burette may be having a tap like this one. Then we may have a burette of this nature. When you look at this one here, it is also having a different tap like that. And then you may find you have a burette which is having a bead inside here. You may have a burette having a bead inside there. So burettes can be of different types, but we are going to see how we are using them. Then we need also a pipette. A pipette is this one here. Pipette is like that. This is a pipette, but take a note of the figure which is always here, this figure. It can be 25 or it can be 20. A pipette can also be like this one. This is also a pipette. This is also a pipette. However, what matters is this value here. It can also be for 25, it can be for 20, it can be for 10. But we are going to drill more or use more, the one of 25 and the one of 20. Then members, we also need the funnel. This funnel I'm talking about, some people don't know how a funnel is looking like. This is our funnel. This funnel we are using for pouring what? Chemicals into our burette. In this way, practical. Then you also need a retort stand. This is our retort. This is our retort stand. When you look at all over this one here, it is our retort stand. The retort stand is having a clamp. This is a clamp, and is having what you call the boss what? The boss head. Then also we need what you call the conical flasks. This one is a conical flask which you are going to use when you are carrying out this practical. This conical flask is also appearing like that. Now, in most cases, we may be required to use a measuring cylinder. Take a note of the graduations here, or the calibrations, the figures which they are writing on this measuring cylinder. Depending on the question, it can be small, or it may also be big like that. But what matters are the figures which are there. We may also use what we call a volumetric flask. This is what we are calling a volumetric what? What we are calling a volumetric flask. In some cases, you may be required to use a volumetric flask, and then maybe a beaker like that one. Glass beaker, it can even be plastic what? A plastic beaker. So to see the colors properly, you may even need what we call a tile. White tile, you may need a tile like that. This one is very, very important as we are going to do what? Titrate. Now, members, after knowing the apparatus which we use in this practical, then we can look at other materials which we need. Always need the solutions. These solutions, they always give you the solutions like when they are labeled like BA1, FA1, BA2, FA2, and so on. You find them put in the beakers. Take an example. This one is BA2. You can even put it in a cup, or you can put in any container provided they are put there BA2. Then you may find someone putting there BA1, for example. However, it can even be DA1, FA1, any alphabet. Don't cram that it must be BA1 or BA2. It can be any alphabet. But what matters, the solution is always given in the cups, as we are going to see. Then you always use what you call an indicator. So, the common indicators which we use, one of them is known as methyl orange indicator. This one here. And another one is known as phenolphthalein indicator. So we are going to see how these indicators are changing. So these indicators are capable of showing us what we are going to call end point. End point now. End point. Or the point at which the acid is fully neutralized by the what? By the base. There we shall get the end point, which end point we are going to use as what we are calling our titer what? Our titer value. Or you can even call it average. You can even call it average titer. Average titer value. Average titer value. Average titer value. We are going to focus a lot on the end point. Which end point we are going to obtain by using these indicators. Now, members, indicators, as you talked about them in theory, these ones are simply chemical substances that have the ability of changing color in acidic medium and basic what? Medium. They keep on changing colors. You can say this one as it is looking here, orange, but when you put in an acid, it behaves differently. Similarly to phenolphthalein indicators, you are looking at it colorless here, but as you are putting it in different solutions, it's going to behave differently. So let me try to demonstrate the issues of colors. Then begin by demonstrating the issue of what we are calling phenolphthalein indicator. Phenolphthalein. So we have what we call phenolphthalein indicator. This indicator, we see it in acid, it is going to be colorless in acid. You discover it is colorless. But again, when you are going to put it in the base, you are going to discover that the indicator is going to turn pink. Pink. You may find in some books they are putting red, but the base color will be pink. So what are we meaning? Let us try to demonstrate it practically. I'm going to get my acid here. This is my acid. I'm going to get my beak and I put an acid. So I'm going to get my acid. This is my acid. I put it there. Someone will doubt that that is not an acid. Now, members, I want to show you how the phenolphthalein is behaving. Naturally, it is colorless, as you can see, colorless. Then you want to see its behavior in acidic medium. So I'm saying this is an acid. The proof which can be done is going to be by using our litmus paper. Remember, even litmus paper here, this one here, is also an indicator, but in the form of a paper. So, if I'm going to put this one, the blue one here, and I put it in my acid, you can see that the blue one is turning what? Red. This one, there's no magic behind, this is only chemistry. If I have it here, so I put it in my acid, you can see it's turning red. So, that one implies that that is an acid. So when I get my acid, and then I add there phenolphthalein, you can, let me get my phenolphthalein now, it is there. Then I'm going to get my drop, I get some drops. Then I'm going to put in my what? In my acid there. When I put the indicator in the acid, you will see no change. The solution remains what? Colorless. Even though the other indicator of litmus has turned what? Red. Now let us try to see if I get a base. Now I have my base here as sodium hydroxide. What proves that it is a base is using the red litmus paper. This is red litmus paper. Then I'm going to get one paper from it, red as you are seeing it. Then I put in my solution there. My solution is turning, sorry, my paper is turning blue as you are seeing. If I get a small leaf, let me get one like that to show you clearly. And then I dip it there. You can see that when I dip here, it is turning blue. Now, let me try to get my phenolphthalein indicator still, and I put it there, and we see the behavior of phenolphthalein in this solution. Now I'm going to put a drop there. You can see, I'll put one drop. The moment so we can clearly see that when I put the phenolphthalein indicator in my base or my sodium hydroxide, that the solution is turning pink. Let me add more drops and you see. I can add and then you see. Now, there we go. You can see the solution here that really we have what we are calling pink. This explains why when I came here, I told you that the indicator known as phenolphthalein in acidic medium, it is colorless. But again, when you look at basic medium, it is turning what? Pink. Even though some books are saying what? Red. But the best idea here will be like this one here. We take that one to be what? Pink. Now, in acidic medium, it was like this. You can see colorless, as we are saying here. This one is the pink, which I'm talking about, as we are writing there. Then, let us try to check another indicator known as methyl orange indicator. Now, when I'm using methyl orange indicator, this is our indicator now, methyl orange. Methyl orange, as you can see, it orange in color. So members, we are saying the second indicator which we can look at is what we are calling methyl orange indicator. This is the indicator I'm talking about. I don't know whether you are familiar with the indicator. You can see that the indicator is orange in color. So from there, this indicator, so naturally is orange, but when you are putting it in an acid, we are going to discover that the indicator is turning red. Our indicator is going to turn red. But again, when we are going to put in a base, this indicator is going to turn to yellow. It's going to turn to yellow. Let us try it practically and we see whether what we are saying, it is true as we are saying it. I'm going to use my base. This is my base. This is my base. I'm going to put here my base. So let me try to put some little base there. That is my base. What you can prove that is a base, I've already told you that method. You can prove by using our blue litmus paper. Our blue litmus paper, putting it in a base, it is going to remain blue. You know that one. But again, when you put a red one, I'm putting blue one, it is remaining blue. But let us put a red one. This one is going to prove that that is a base. Red one, I put inside. There we go. The red one is also turning blue. That one indicates that this is a base. In this base, I'm going to put there some drops of my indicator. This is my indicator and my dropper. Then I put some drops there. And I put the first drop. Then you can see what happened in the solution. Then if I add more and you check what is going to happen. Now comparing this color and this color, you can see a very big difference. This is the yellow one we are talking about in the base now. This is the base, the yellow one we are talking about. Then let us try the same when you are using an acid. I'm going to get an acid which I used when I was carrying out that one for phenolphthalein. I put my acid there. Someone may say that maybe that one is not an acid. We can prove it by putting litmus. Litmus, as teachers told you, litmus can show us whether something is acidic or basic. Blue litmus and an acid litmus turn red. So I get my blue litmus, I put here in my members. So you can see that our solution here, the solution has made the paper which was blue to turn what? To turn red. Now this one, it implies that this one is our acid. So let us try to put our methyl orange and you see how it's going to behave. I'm going to put some drop. That is the first drop. And then I shake a bit. I can even add another drop. And then we see. When you add the second drop, you can see that the solution is turning to red. You can see our red we are talking what? About. Now when you compare the three, this one is the real color of methyl orange. This one here, try to look at it. Now in this one, we added a base. Try to look at this one. We have a base there. Then in this one, we have an acid. So this explains why when we came back here, we said in an acid, methyl orange is giving us a red. You can see. Then when we put it in the base, this is the yellow which I was talking about. So we can now conclude that in acidic medium it is turning red. Then in basic medium it is turning yellow. So members, we have to master the color changes of those indicators, because as we are looking for our end point, remember we said our journey is to obtain what we are calling end point. When you are titrating, as I'm going to show you, you are going to discover that the end point is going to depend on the indicator color change. A clear image about titration or qualitative analysis. Let us try to do this question practically. This man or this woman is saying, you are provided with the following. Is saying we have what we are calling BA1. Is providing us with BA1. which is made by dissolving unknown mass of sodium hydroxide. At the same time, is saying we have Ba2, which is 0. Take a note of this one, which is 0.1 molar sulfuric what? Sulfuric acid. Then in our procedure, remember when you are doing this work, you have to read the procedure properly. Your marks or your results are going to rely on the procedure. Or you have to give it a lot of time. They are saying in our procedure here, this is what we are going to do, that we pipette 25 cubic centimeters. That one means we are going to use the pipette of 25. Pipette of 25, that is the 25 they are talking about, or 20. So it depends on the pipette they have what? They have given you. We say they can write here 25, or they can write there 20. So from there, you choose one to use. You may use 25 if the teacher has given you 25 pipette, or you can use 20 if they have given you 20. Then from there, they say we add 3 drops of phenolphthalein indicator. So let me begin by pipetting what they have told us. I'm going to obtain my BA1. This is my BA1. I have my BA1 here. This BA1 is what they are telling us here to do what? To pipette. So I are saying pipette 25 cubic centimeters of BA1. So I get my BA1 here. Then I pipette. Pipette means you get your pipette. This is a pipette. This one here. You put it in the BA1. They have told you like that. After putting it there, it implies that you put your mouth. You put your mouth like that. Then you suck. So when you are sucking, there is a line which they indicate here. Try to be observant. There is a line here. So what do? We reduce a bit until when you reach that line. You can see our liquid going down. Our liquid going down. Then we pause there at the line which they want. After doing that, the man has told us to transfer our liquid into a clean conical flask. So what are we doing here? I transfer into my conical flask here. This is my conical flask. I put my liquid. I can even blow air to remove all the liquid from my pipette. That is the meaning of pipetting. Then the man is saying, add 3 drops of phenolphthalein indicator. That is procedure number 2. Then I get my phenolphthalein indicator. It is there. It is my phenolphthalein indicator. It is my phenolphthalein indicator. Colorless as it is, as we said. Then the man is saying, add 3 drops. Then you get your dropper. You suck a bit like that from phenolphthalein what? Indicator. We add it to where? We add in the solution which you have pipetted. This is our solution which you have pipetted. Then we come and we add, that is it. Now, the drop. When you add a drop, the man has said 3 drops. But even if you use 1 drop, it can what? It can work. There we go. Now, I've used the 2 drops. Then I add the 3rd drop, if I want. But following the procedure they have said, then I add the 3rd one. You can see now the solution is turning to pink. Now, after doing that, the man is saying,